This is going to be 34-3, and this is going to be the third example for curve sketching. We've already been through the steps. If you would like to pause it to revisit them, go for it. All right, so here's our first example. It's x squared plus 1 over x squared minus 9. Now, this is a rational equation, so that means that when we have to find the domain in the end behavior, okay, that's going to be possible vertical and horizontal asymptotes. Now in this instance, there are vertical asymptotes because if you set the bottom equal to 0 and you solve for it, you're going to get x equals 3 and negative 3. When you plug them back in, you're going to get an instance other than 0 over 0. So you're going to get a different number over 0, and so therefore they're vertical asymptotes. And for the horizontal asymptotes, remember we have to look at the degrees of our polynomials, or if I take the limit as x goes to infinity of this, right, it's going to reduce down to 1. So either way that we look at it, just know that we do have a horizontal asymptote, and so that represents our end behavior. Next, finding the x-intercepts and y-intercepts of the function. So for the y-intercepts, if you plug in 0, you're going to get 0, negative 1/9, and there are no x-intercepts. And the reason is because if you set the top equal to 0 and solve, you're going to get an imaginary number. So the numerator is going to be always positive. Then we need to find the first derivative. So here's all of the fun work for that, right? Low d high minus high d low, denominator squared below, and kind of cleaning whatever that is going to be up. So once you do that, you have to set it equal to 0 and solve. And so the values that you're going to get is you're going to get 0. That's going to be a critical number, but we cannot forget the undefined values. And so down here where it's undefined, if you set those equal to 0, you once again get 3 and negative 3, which originally were our vertical asymptotes. And so putting on those number lines, we need to take a look at our intervals in increasing and decreasing, because that's also going to help us to determine what our max and min is going to be. So it's positive, positive, but that is also a vertical asymptote. Positive, negative. So if it's going up and then going down, we know that that's going to be a relative maximum. And then negative, negative, that's going to be a vertical asymptote. Well, it is a vertical asymptote in between, so that's not going to be anything special. Now I need to find the second derivative for my inflection points in concavity. So once again, here's the fun math of finding that second derivative and cleaning that up. I know you may have to pause it to kind of be like, whoa, how does that simplify? But that's what it needs to simplify into. Now, looking for those inflection points, remember we have to set it equal to 0 and solve. Now, when we do that, what's going to end up happening is you're going to get imaginary values for x. So therefore, there is no inflection point. So your vertical asymptotes, we still have those, right? Because if we set the undefined values, or if we find the undefined values and set the bottom equal to 0, you're going to get negative 3 and positive 3. And so this is going to be the increasing, I'm sorry, not increasing, but concave up, concave down, concave up. And so that's going to help us with our sketch. All right, so now putting all the pieces together, the first is going to be, remember, the domain and the end behavior. So we said we had vertical asymptotes at x equals negative 3 and positive 3, and horizontal asymptotes at y equals 1. So we put those on our graph. Then we need to plot the x or y-intercepts, and so we have the y-intercept at 0, negative 1/9. Now we have a maximum at 0, negative 1/9 as well, because if you remember, that value of 0, if you plug it back into the original, it's going to give you that negative 1/9, and so I know that that value, which is also the same as my y-intercept, is going to be a relative maximum. And so now, interpreting what we have with, we said there's no inflection points for the second derivative, but we need to take a look at the concavity. And so because this is going to be concave upward, right, I know that it's going to be over here. Because this is going to be concave down, I know that this has to be facing down here. And then that's concave up, so that's going to be facing this way. Now, remember, these want to hug the asymptotes. So when we draw them, you draw the graph hugging the asymptotes. And I know it's not ultra accurate, but it is enough of a sketch with the math that we did to where this is basically all the important information that we do need. So this concludes the third example. If you have any other questions, please leave them in the comments.